the first demo that I'm going to do, we'll start with an example of how to stop data exfiltration. I'm going to run through a full demonstration how network observability can be used to detect pods or processes. And I'll explain the distinction, communicating outside the namespace or cluster and potentially block suspicious pods upon detection. So for this scenario, let's imagine a pod with permissions to communicate outside, let's say outside the namespace or outside the cluster. Now, assume the pod is compromised and a malicious program is installed. This program starts sending and receiving encrypted traffic to and from an external destination. Since the malicious program shares the same IP as the pod, it becomes extremely difficult to distinguish between the malicious traffic and the legitimate traffic generated by the pod. Okay, so for that, let's assume that I'm a hacker, right? And I'm able to SSH into a certain running pod, right? So I'm now in the pod. I'm now in the pod, and I'm going to connect to my very malicious, remote portal named Google. So I got, what I was looking for. I may have sent something instead of receiving. Now, let's do it again. Oops, I'm unable to. Okay. So what just happened? Right. And I'm gonna, basically, I'm starting from the end, going all the way to the start to explain exactly what happened here, okay? There's a network processor, which is basically a hook, okay, that is triggered on every API call, okay? It processes all API calls, and that hook specifically is programmed to detect processes communicating outside of the cluster, and then report those pods and processes. Where did they go? And then report those pods. The processor detects a malicious process. In this example, I use the CURL and then calls a helper function that blocks the ingress and egress of the suspicious pod by applying a network policy. Let's see it again, but now with kind of the full explanation. I'm going to use Kubeshark to show what's going on in the traffic. But before that, let me prepare. So this is the normal traffic. No, no malicious entities, right? And I'm now going at it again. But before I'm showing you what's happening, let's focus on external connections only. Currently, I have only two connections to the outside, okay? And I'm SSHing in. And I'm doing CURL and same thing I did before. Okay. So this is the new connection, okay? And when I try to do it again, I couldn't, okay? Why? Because the first time around, a new network policy was added, okay? When the pod was detected, a new policy was added to block ingress and egress of the specific pod that was kind of detected. Okay, how this was done? Remember, I talked about the network processor. If I look at the report that was generated by the network processor, I scroll back, and I see a certain action was triggered, block pod, process CURL, pod, whatever was detected, the destination, right? And if I see the actual network processor, this is the network processor. Okay, it's code. Basically, it's uploaded to Kubeshark and runs. And again, as said, there is a hook. The hook is triggered every time there is a new API call, and it makes calculations, right? This specific hook search for public destinations, aka going outside the cluster, doing some sort of calculation, and one of the actions would be if, in fact, the process belongs to a list of malicious processes like CURL. In this example, again, it's a very simple example. Use a helper function to block the pod. So this is the full-blown network processor. Right. Okay, so that is that. Let's see if I forgot something here. Yeah, okay, network processor detecting the outside connection, triggering a helper function that applies a network policy that blocks the pod. Let's go, with your permission, let's go one level deeper to discuss what is a network processor. So a network processor inspects all traffic and makes calculations on data found inside the traffic. It can create custom reports like the one you see. This is, for example, right? And again, the report is created on the fly using this code. This is a simple JavaScript code that also creates the report. It can create custom metrics and export to other systems like Grafana, Prometheus, Kibana, etc. I'm going to show this in the second demo. And it can also export the entire traffic to be scanned by API security scanning solution. Again, as an example, you can export traffic also for forensics, for compliance reasons, for any reason you want to see the traffic outside in an immutable data store. There are multiple ways to create custom network processor tailored for your need. One, you can modify or use an existing one, build one from scratch, or use GenAI to create it. The next demo will show how I ask a question in a natural language and to a GenAI assistant trained by us that will generate code for a custom network processor. And the processor can be refined and refined until perfect. With that, I'm going to use an OpenAI custom GPT with the same training of our Kubeshark assistant. Again, by the way, all these things are things we are currently working on. You can basically ask any question or request any sort of automation and get in return code for a network processor that can be uploaded and executed by Kubeshark. So let's give it an example. Kubeshark, show me the top 5 pods consuming the most. So again, this is OpenAI trained by us. with basically providing all of our scripts and telling what you should do in most cases, and obviously OpenAI's capability to generate code. The outcome, usually the code is perfect, like no bugs, it runs, it doesn't always do what you want it to do, so it's like 5% you may need to help it, not in this case. So once this is done, obviously it also explains what it is, what you should do with it. You copy the code and you go to Kubeshark, you add it and run it. In this case, this is the code I ran it earlier, so it will start generating the report quicker. So in this case, for example, these are the top 5 DNS consumers, right? In terms of the rate and the number of DNS consumers. Why this is good? Whenever you have rate limiting and you want to avoid that, like with GKE, for example, this can be very helpful. This specific report and the other one, which shows the same for endpoints, top requested endpoints by DNS server, kubedns, etc. These also generate custom metrics and export it to Grafana, just to show how it's done. In this processor, there is a single line somewhere. Here it is. Prometheus, metric name, metric description, the value and labels. And this metric, the minute you define this, and it could be anything, any new custom metric with any new value, no need to do any other thing, right? It will export it to Prometheus and then be read in Grafana, and you can build your own dashboards based on these custom metrics. Again, for this purpose, it's the DNS consumers, endpoints, and servers. Okay, let me see where we are. Got it. Okay, so this is basically the two demos, the 2 live demos, and just to finalize, what is, for those of you who don't know Kubeshark, Kubeshark is a GenAI assisted network observability platform for the scale of Kubernetes. It monitors 3 sources of information: the Kubernetes API, the Linux kernel, and the network interface. It uses technologies like eBPF and AF packet to capture and process all traffic everywhere and at all times, the entire cluster, no matter the size of it. It correlates related operating system events as well as Kubernetes events, so you can have the full picture and the context of what's happening on the network.